monitoring, level control of liquids, metrology applications. Measure shape errors in the part being produced to analyze and optimize the rotation of spindles in various machine tools such as surface grinders, lathe, milling machines, and air bearings spindles by measuring errors in the machine tools themselves. So assembly line testing to test assembled part of uniformly thickness or other designs. Like that we can use the capacitance sensor. This is another sensor, that is linear displacement measurement using variable area based capacitor. Same here we are calculating the sensitivity. So sensitivity depend of change of capacitance with respect to the change of length. So that is we can call as the unit of sensitivity will be force per meter. Okay, that is epsilon 0 epsilon r W divided by T. So W is the width of overlapping part of plates. So L is the length of overlapping part of plates. Okay. So next one, eddy current proximity sensor. Okay. So first we need to know about the eddy current. So when we are using high frequency magnetic field with the conductive material, so the conductive material produce the current flow, or it will produce some magnetic flux in the material. So it will produce some current in the output. So that is eddy current. Okay, that is a material induced by the high frequency magnetic field. Okay. So that technology used in the eddy current proximity sensor. So eddy current proximity sensors are used to detect non-magnetic but conductive material. Okay, they comprise of a coil, an oscillator, a detector, and a triggering circuit. So when an alternating current is passed through the coil, an alternative magnetic field is generated. If a metal object comes in close to the proximity of the coil, then eddy current are induced in the object due to the magnetic field. Okay, so these eddy current create their own magnetic field, which distorts the magnetic field responsible for the generation. So as a result, impedance of the coil changes, and so the amplitude of alternating current. This can be used to trigger a switch at some predetermined level of change in current. Okay, so eddy current sensors are relatively inexpensive, available in small size, highly reliable, and have high sensitivity for small displacements. Okay, this is a setup for eddy current proximity sensor. So this is the target material. So this circuit LC circuit produce the oscillation high frequency magnetic field. So using this, the material will be induced. Then it will produce some eddy current. That eddy current produce some magnetic field will affect the input section. So using this values changes in this LC value, we can amplify the detecting circuit value. Then output. Then we can calculate the variations. Okay, that is a distance between proximity sensor. That is distance with the material. So application of eddy current proximity sensor, automation, recurring precision location. So like that they are using machine tool monitoring. Then final assembly of precision equipment such as disk drive. So like that they are using. So measuring the dynamics of a continuously moving target. Okay, measuring the dynamics of a continuously moving target such as a vibration element. Okay, then a driving shaft monitoring, like that they are using the eddy current proximity sensors. Then Hall effect sensor. So Hall effect, so this is a Hall effect sensor work on the principle that when a beam of charged particle passed through a magnetic field, force act on the particles and the current beam will deflect from its straight line path. Okay, so this is a simple concept. Okay, when we are take the magnet to the current moving material, that is current induced material. So a flow of electron will be changed due to the magnetic field. Okay, so normally electron will go this like, that is straight line. For example, if it is a one millimeter means, so after applying magnetic field, the electron moves like this. So these variations, so electron move for more distance. For more distance means it will produce more current in current, and it will produce some more differential voltage. Okay, so we know that flow of electron will be current. Okay, that is here they are using. So electron flow will be varying. So using the various of Hall voltage, we can identify the position of magnet, so where it is. Like that we can calculate. That is Hall effect sensor. So thus one side of the disk will become negatively charged and the other side of will be positive charge. So this charge separation generate the potential difference, which is the measure of distance of magnetic field from the disk carrying current. So application, the typical application of Hall effect sensor is the measurement of fluid level in a container. The container comprises of a float with a permanent magnet attached on its top. A electric circuit with a current carrying disk is mounted in the case. So when the fluid level increases, the magnet will come close to the disk and the potential difference generates. This voltage trigger a switch to the stop the fluid to come inside the container. So these sensors are used for the measurement of displacement, so and the detection of position of the object. So all effect sensor need necessary signal conditioning circuitry. So they can be operated at 100 kilohertz. So their non-contact nature of operation, good immunity to environment commitments, contaminations, and ability to sustain in several conditions make them quite popular in the industrial automations. Okay, thank you. Okay, so these are the basic concepts of strain gauges. Okay, then capacitive sensors, then proximity sensors, then Hall effect sensor. So these all the sensors are identify the displacement, then small displacement. So change of small displacement with respect to the distance change. Okay, simply we can say in short form, strain gauge means, so when resistance change, we can calculate the displacement. When capacitance change, we can calculate the displacement. That is capacitive sensor. In eddy current, if there is no current changes, so eddy current produce some induced flux. If flux changes, mean we can calculate the proximity value, that is distance. Hall effect sensor also, if we vary the magnetic field, that is magnetic location, we can calculate the position of the metal. Okay, like that we can calculate. So these are the 4 concepts of sensors. Okay, thank you. We will see in the next class.